Thank you very much, and good afternoon, everyone. It's my first time at SciPy, also my first time in Texas, and this room is like the Texas I imagined, wide open spaces with few people in between. Before I start on the talk, I just wanted to give a little bit of an introduction about myself. So I'm a developer at Microsoft Research, and the project I'm going to talk about today is really my first foray into Python and the Python world. To give you a sense of the type of projects that I've been working on in the past few years at Microsoft. I've worked on the F# language. So if you guys are familiar with functional languages, F# is a newer language in that space. I would invite you to take a look at it. It's open source. And one of the projects I did was a website. Oh, it's actually not showing on the screen. Sorry about that. Okay. I'm going to try to deal with that. I can't see it on my screen anymore. So it's a website where you can actually try the F# language online. Then I also worked on, I'm not going to be able to do that. Okay, well, I will move on without the browser for now. It's going to be very difficult, but so I also worked on a project called the Worldwide Telescope, which is a tool for visualizing both the sky and also the Earth. And I was actually going to point to a web page which has a Python interface to interact with the Worldwide Telescope. That may be interest of some of you if you're in maybe astronomy or visualization. And I also worked on the machine translation, doing a project called the Translator Hub, which allows people to create customized translation systems so that you can then use tools like Bing Translate with your custom systems. But today I'm here to talk about CodaLab, which is a system for doing research, especially in machine learning. So the objective for CodaLab is to create a collaborative ecosystem for conducting computational research in an efficient way, but also in a reproducible way. And also in principle, we'd like CodaLab to be applicable to any kind of computational research. In practice, we're really focused on machine learning and on medical image analysis. And the reason for doing that are twofold. The first fold is that you need to have focused use cases in order to develop a system. And the second fold, of course, is that the collaborators we have are working in those spaces, and therefore that's what they want to do. Now, this statement is pretty broad, and I'll try to sort of, give you motivation, but also go into some details about it. So this is the outline. We'll start with some motivation, fairly high-level statements, but then I'll try to go deeper into what the site actually does today, and what are the design principles behind it. And we'll focus on two sort of key pillars in CodaLab today, which are competitions and also what we call worksheets, or a way to document an experiment so that it can be reproduced by others, but also understood by others. And finally, I talk about the open source project. You may wonder why give that talk here at SciPy. And of course, it's because behind the project, there's a strong Python story. And I'd be interested in telling you about it. Before I go into the talk, I'd like to give acknowledgements. Even though I'm the speaker today, it's clearly the work of many people, and I would like in particular to acknowledge the people who have taken the lead for that community, CodaLab being an open source project. The first one is Percy Liang, who's a new professor at Stanford. He started, I believe, 1 or 2 years ago there. And another one is Isabelle Guillon, who basically runs a challenge organization, which is an organization that hosts many challenges in the machine learning space. And she's really interested in using that platform for what she does. You may not be able to read it, but behind the name of those two community leads, there's an agenda, and that's because next week, actually in Redmond, we're going to have the first meeting for the people who are interested by the project. And so if you're able to read, you'll see other names of people. There are people from Microsoft Research, a researcher from Microsoft Research. There are PhD students, I think one from the Netherlands, one from CMU, and then there are other people from academia doing medical image analysis and so forth. And then even though CodaLab is fairly young, it's less than a year old in terms of a project, we're fortunate that we've had quite a few people already contribute code. So if you go to GitHub, I'll give you the URL later, you'll be able to see the list of people who have participated. PhD students coming and going, so the level of contribution varies, but any piece helps. So let's give a little bit of motivation. I'm not a researcher myself, I'm a developer, so I'm going to use the words of Percy Liang, who was a professor at Stanford, and he gave a presentation maybe about a year ago, and he was talking about the current research process. And that process really is fraught with challenges. So ideally, you'd start with an idea, and you'd be able to proceed with that idea and test it and validate it without losing time. But the reality is not that. There are a lot of steps that impede the progress on the research. For example, you may develop an algorithm and you want to compare it to an existing set of results. Then you're going to read a paper, and from that paper, you're going to learn about the algorithm that someone tried, but then you won't have the code. So then you'll have to try to find the code, maybe by emailing that person. If you're lucky, you'll get the code. If you're even more lucky, you'll be able to run it on your machine and try to make some fair comparisons. And there are other problems. Some of the comparisons are not always possible. For example, one researcher may apply an algorithm on dataset 1, and another one may apply it on dataset 2. They get different results, but how do you compare them? There's no basis for comparison all the time. Or maybe the parameters are different. The experiments are not controlled in the same way. So it's very difficult to compare apple to apple. And finally, there's a general lack of a broad overview. So, I think machine learning in the past year or 2 years or so has really exploded. It's almost become a buzzword. But if you talk to the expert, they actually have a hard time in many cases recommending methods to the layperson, because it's a little bit like maps of the Earth a long time ago. There were some ideas, but they were not very accurate. And the communities could really benefit by having more structures and much more informed information, so that when you have a problem, say you have data and you want to apply an algorithm, you can make informed decisions as what algorithm you should be choosing. So clearly, we can do better, and we believe that what is needed is a system where waste can be avoided. You can reuse tools, you can reuse data sets or programs, find them easily, and also, as people publish new content, we have to take into account reproducibility by default, not as an afterthought. And that, in turn, will allow us to enable, to set common measures, have fair comparisons, and then we also have to take into account the community, because a lot of the research problems that are more interested are not one person working on one problem. It's really a community contributing at different levels. So we can evolve from competitions to more of a cooperations with some competitions, so what we call co-petitions. So we hope that CodaLab can be a community site, so it can be that place where people can come and actually do better research. We're not claiming that CodaLab will solve all the problems of the world, because there are difficult problems to tackle, but if we can make increments step by step, I think the place can be better overall. And so CodaLab offers really two aspects of it, and I'd like to describe them to you, but also convince you that they're not independent, that if we manage to bring them together, then actually they are better together in the story. So one pillar is competitions. How does one community focus on a problem and bring different minds together to solve that problem more effectively? And the other one is through the use of what we call worksheets. How do people describe their experiment in a way that's more reproducible? And also, in so doing, collaborate on workflows, but also share their results, whether share their data, share their programs, and share their know-how. So let's move to competitions. And because of the difficulty with the screen, I think I was planning to show you the site live, but I have some backup slides, and I'm going to use the backup slides instead. So if you were to go to CodaLab.org on your laptop today, what you would see right now are only competitions. And so on the competitions page, you can see a list of competitions which have been created by competition organizers. And if you were to pick one, like this one, you would be able to see 3 tabs, which leads you through what a participant in that competition would typically do. The first one is learn about the details of the competitions. Those details have been provided by the competition organizer. Now, one thing I want to point out is that competitions are quite common in the research community. There's, for example, a computer vision challenge, the Middlebury challenge, which has been running for a very long time, and you can go to their website and you get a list of results. They have metrics, you can see the values, they have reference to papers. But again, if you were to follow up on the paper, it would be a lot of work for you to actually figure out, what was the algorithm applied in that sense. And there are other examples in the medical imaging analysis. For example, there's a site which collects a list of grand challenges. But then if you click on every competition, you see that the scientists basically build their own website or some infrastructure themselves. And clearly, it shouldn't be the role of the scientists to do that work. They should focus on the research problem. So what we're hoping is that CodaLab, simplifies for them the process of creating the competition. And so we have some form of a template. They still have to provide a lot of information, but at least they can get a competition set up fairly quickly. Once you've done it once, you can set up another competition in a matter of hours, really, provided that you have the problem framed already. From a participant point of view, you would decide to participate in the competition. Some competitions are open to the public, some require approval from the competition organizer. And then you would create a zip file, which is your submission to the competition. What the zip file contains is really provided, specified by the competition organizer. You would upload it to the system, and then the CodaLab infrastructure would automatically invoke a scoring program which has been provided by the competition organizer and provide scores. And those scores would be reflected on the leaderboard. There are a lot of features that I don't have the time to go into. One key feature that I wanted to mention is the fact that each competition is segmented into phases, which typically corresponds to how people do challenges today. So basically there's a period of time where you get a certain amount of data, you work on the problem, and then you move to the second phase, you get new data, and you continue on that phase. We also have the ability to do more advanced leaderboard. And in terms of the competition creation, the way it is done right now is that as a competition organizer, you need to create a zip file, a bundle of information, which has both metadata about the competition, data about the competition in terms of what the description will be for the participant, and also you need to provide a scoring program and a reference data set. Then you upload all of that, the competition gets created, and then you can go to my CodaLab to manage your competitions. And then there are different tools to manage the competition, see the participants, see the progress, and also an editor which allows you to edit some aspects of the competition. And those are things that could be full-featured over time, but for now that's what we have. So hopefully that gives you some kind of an idea about competitions. Two key points to take away is that on one hand, CodaLab streamlines the process of creating competitions to help researchers focus on the research problem. And right now, most of the competitions that we have on the site involve participants submitting data, but one of them already has moved to asking participants to actually submit their code so that we can run their code, produce their results, and then score their results. And that's an important step in moving towards reproducibility, because now we have a system that enforces that a competition participant entry will only be valid if we actually have managed to run the code, which in past competition has not always been the case. Of course, you could argue that that's a nice step, hopefully, but it's not sufficient to capture more detail about the competition entry. And that's where the other side of the CodaLab system comes into play. It's CodaLab workflows. CodaLab workflows are really about experimentation. And the idea is, if you look at most AI or machine learning systems today, like the ones I've worked on for translation, the input may be a sentence in a language and the output is a sentence is another language. But the system in the middle that actually does the translation is quite involved, and it has a lot of pieces, and different researchers will contribute to different pieces of the system. So the entire system is, you really have to look at it as a graph, a directed graph, where every node in the graph is a module. And you want to give people the flexibility to sort of start with the system and focus on the module and swap it so that they can do their experiment and see how swapping that module results in different results. So that's why when we look at experimentation in CodaLab, one key aspect is modularity, making sure that we define blocks, modules that encapsulate an aspect of the system. Internally, we talked about bundles. A bundle represents either a data set, a program, or a run. And so when we look at the flow, really, the input node in the workflow may be a data set. That data set may be fed into a program. And the combination of the data set and the program plus some parameter define a run. And the output of the run is another data bundle, which is really result. And that then can be fed into a next phase into the graph. Another principle is one of immutability. And again, here it's to facilitate reproducibility and also to enable collaboration without chaos. So the idea is that if you create a data set, you write it once and then you cannot change it. If you want to change it, you basically create another data set. And the final one, which really is inspired by systems like IPython and Mathematica, and one where we may look at more interaction between the systems, is one of literacy. So it's nice to produce results that you can reproduce, but at the same time, it's important to give people the ability to give explanation about those results, so leave room for interpretation. And so in the system for CodaLab, we have worksheets which allow you to interleave the dataset, the programs are run, with textual explanation, very much like an IPython notebook. So again, because of the problem I have, I'm going to skip the demo and go to some backup slides. On the main CodaLab site, we don't have worksheets enabled, but on our test website, this is what you would be seeing. Just like competition, there's a list of worksheets. If I click on a worksheet, I can actually read it. So like the IPython notebook, you start by reading the test and then you come to some blocks. In our case, the blocks are not pieces of code, they're actually bundles. So the first one in this example is a data set. So I can actually see the data set that was captured by this experiment. And using a current editor, you could actually drill into the data set, see that it has a few files, click on a file, and then see that that file is actually a little poem. And then this experiment goes on by then including a program which is the Stanford Core NLP library, which is used to interpret those poems and break the text into tokens. And the final piece of result is actually what the analysis produced. And in this case, we have a visualization of the analysis of the text, showing each word as being a token, a noun, a verb, and so forth. So in a nutshell, that's what a worksheet is in the website. The way we create worksheets right now is actually through a command line tool. We have a command line tool which allows you to basically it runs on your laptop and you interact with a remote server. We use OAuth for authentication. And so using those commands, you can create worksheets. And then as you add programs or data set to your worksheet and as you do run, that history is automatically captured in the worksheet, so that when you look at the worksheet, you see that you use that data set, you use that program, and that's how we capture the process of your research. So in a nutshell, we have those two systems that we're working on. On one hand, competition, on the other hand, experiment, and how you describe them. And where we really would like to be in the future is really marry the two. So you can imagine that as you participate in a competition, you really start with your experiment, which is to say, I'm starting with that data set, I have that problem to solve, I'm going to apply that algorithm, and this is the description of my work. And then using the command line tool, instead of just creating a worksheet, you can submit it to the competition, and then your result come out. And then when people look at the result of the competition, then they can get a link back to your worksheets, and then a link back to the actual steps that you took to solve that problem. So that's where we'd like to be in the future, and clearly we are not here today. Briefly about the project. So CodaLab is an open source project hosted on GitHub, github.com/CodaLab. We have two repos essentially, one called CodaLab, which is the website and the OAuth server, and then one which is CodaLab-CLI, which is the CLI tool, and some services that support the CLI command tool. It's written in Python, so we make use of probably the typical framework, Django host, toolkit, and so forth. Of course, we make use of the typical tool like Travis CI for continuous integration. One tool that I like to use personally is PyLint. Coming to Python, it's kind of hard for me to not have a compiler to check my mistakes. And having a tool like PyLint, I find is a good way to catch some of them, but not all of them. It's amazingly easy to mistype a variable name in a Django template, and then you don't know until you run into the issue. One characteristic of that project is that we have people working on Windows, people working on Linux, so we try to support both of them, which is not always very easy. And finally, the CodaLab project is cloud-hosted, and we're using Windows Azure. And so if you're not familiar with Windows Azure, I would invite you to take a look at it. A lot of people I talk to are actually surprised by what's available there. So we actually provision Linux machines in that cloud provider, and then run the website on those Linux machines. And then we take advantage of services such as MySQL, which is a hosted service, SendGrid, which is a way to send emails, and service bus for messages and so forth. And if you're researchers also, I wanted to give a little plug for the Azure for Research program, which is a program that's currently run by Microsoft Research, which allows you to apply for grants so that you can actually do research on Windows Azure. So in conclusion, I hope you have a slightly better understanding of what CodaLab is. We're hoping that it can be a system that can be useful to the research community to serve some of the goals that will improve the research process. If you're interested, I would invite you to be part of the solution. Maybe you have a competition you'd like to host, or maybe you'd like to become a developer, contribute a feature or more. We're quite happy to have new people join on board, and that was one of the motivation for coming to SciPy this year. So thank you very much for listening. I'm happy to take questions now, or later I put my email address as well if you want to contact me that way. Thank you very much.